In this video, we are going to talk about limits at infinity. Okay, so this is section 3.5 in the book. So before we start limit at infinity, I am going to review some of the concepts on horizontal asymptotes and how do we find out the horizontal asymptotes. This concept is from the college algebra. Okay, so what do you mean by horizontal asymptotes? If when you go to the very right, if the graph of the curve going to some horizontal line, okay, for example this, when x tends to infinity, meaning when you take bigger and bigger values of x, if the height of the function is close to a horizontal line, or you can go to the right, when you go to the right side, you may go from the below or from above, right? The another possibility can be you can go like that, right? You can go to that dotted line from either direction. So what does that mean then? So that means if limit x tends to infinity or minus infinity, right? So f of x is equals to plus is equals to a number c, okay, or it could be limit x tends to infinity, negative infinity f of x equals to c, then y equals to c is the horizontal asymptote, right? Then y equals to c is the horizontal asymptote. Okay, so basically the limit at infinity is basically we are trying to find out if there is a horizontal asymptote or not. Okay, if the function approaches to a number or not when you take x tends to infinity. Okay, so when do we find out the horizontal asymptote, or in other words, when do we find out the limit x tends to infinity fx over gx? Do you remember the definition of the rational function? What do we mean by rational function? Rational function. So we are trying to find out the limit of the ratio of the functions. But first of all, what do we mean by rational function? So if there is a ratio of two functions where the first function is a polynomial function and the second function is also polynomial function, so this will be the rational function. Okay, meaning the first function or the function on the top have exponent either 0 or positive whole number, and also the function on the bottom is either have exponent either 0 or positive whole number. In other words, you say that the ratio of the two polynomial functions is called rational function. Okay, the ratio of two polynomial functions, because the polynomial function is the one that has the exponent either 0 or positive exponent of x. Okay, similarly the bottom function. All right, so the ratio of the two polynomial function is called the rational function. Now each of the polynomial function have some degree, right? So the degree is the highest exponent. The degree can be a highest exponent. Sometimes if there is a product of x's, then in that case the degree will be added. Okay, so first of all, let us talk about how do we find out the limit of the rational function. Okay, limit of a rational function, meaning the top function is a polynomial function and the bottom function is also polynomial function, meaning that they have some degree. So how do we find out the limit of that, or finding the horizontal asymptote of a rational function? That they are the same thing. Okay, finding a limit of fx over gx where f and g are the polynomial function, or finding the horizontal asymptote of the rational function fx over gx. Okay, that's the same thing. Now how do we find out that? This is again from the college algebra. If the degree of the top function, this is, let's say this is a top function, this is a bottom function, right? If the degree of the top function f is smaller than the degree of the bottom function, then the limit is always 0. I will show you how that will be 0, right? But you just relate that from the college algebra. If the degree of the top function is smaller than the degree of the bottom function, then the limit is always 0, or the horizontal asymptote is 0. Next, if they have the same degree, if the top and the bottom have the same degree, then limit x tends to infinity fx over gx is the ratio of the leading coefficient. Look at this, L dot C dot means leading coefficient. If the top and bottom have the same degree, then the limit is the ratio of the leading coefficient. And if the degree of the bottom is bigger than the degree of the top is bigger than the degree of the bottom, meaning the top has top polynomial has bigger degree than the bottom polynomial, then in that case this limit will be infinity. In case of the infinity, we call infinite limit, or we call does not exist because it is not finite. Okay, so the finite limit does not exist, so it is infinity. We also call this as a infinite limit at infinity because the limit is at infinity and then the limit is also infinity there. So infinite limit at infinity. Okay, let us also review what are the indeterminate form. When you plug in the limit, basically any problem, if you have the limit, okay, so the first thing you want to find out in the limit is try to plug in that value directly. If you get 0 over 0 or infinity over infinity or infinity minus infinity, 0 times infinity, 1 to the infinity, infinity to 0 and so on, then in that case we got indeterminate form. In that case, if you get indeterminate form when you plug in the limit directly, okay, then what we do is we do not plug in the limit directly. What we do, we try to simplify or do some extra thing before you plug in the limit. Okay, that thing we will see that in the examples. Now, can you tell me what is the value of c over infinity? C is a number, a finite number, and if you divide by a huge number, then what is that ratio? It is always 0, right? If you divide a finite number by infinity, it is 0. It can be plus infinity or minus infinity, but you will get 0. Okay. Now, next thing is, if you divide infinity by a number, it could be plus infinity or minus infinity. If you divide by a finite number, then that will be plus minus infinity over c will be basically plus minus infinity itself. So don't get confused with that. If you're dividing a finite number by a big number or very small infinity or big infinity or plus infinity and minus infinity, it is always 0. And if you divide plus or minus infinity by c or multiply this by c, will give you plus or minus infinity. Okay, so let us do this problem. I will show you how this problem in two different ways. One way is I will just use the rule number 1. Look at this. You want to find out the limit x tends to infinity, x square plus 2 over x cube minus 1. You can think like f over z, right? Now, how do I find out the limit here? If you plug in the limit directly, what do you get? Infinity square over 2 is infinity over infinity, right? See, if you plug in infinity on the top, you'll get infinity square plus 2 is infinity, and on the bottom, infinity cube minus 1 is also infinity, right? So it is one of the indeterminate form. So the way that the rule says, what does the rule says here is, what is the degree of the f is 2 because the highest exponent is 2. Degree of the bottom is 3, right? Because the highest exponent on the bottom is 3. So the degree of the top is 2, degree of the bottom is 3. So in that case, what is the limit? Limit x tends to infinity, x square plus 2 over x cube minus 3 is basically 0 because it says the limit is 0, right? Because the degree of the top is smaller than the degree of the bottom, so it is 0. So this is one way. The other way is, without using this rule, what we do is, what is the common on the top and on the top terms? There is no common on the top because there is x square, there is 2, right? There is x cube, there is 1. There is nothing common. But what you can do here is, you can use a trick like limit x tends to infinity. Let me take x square out from the top. X square out. What is left is 1 because you took the x square, right? And then plus, since there is no x square, we just took x square out, means you can do 2 over x square, right? Because when you distribute this, you will get x square over 2. So if there is nothing but you want to factor out something that is not there, you will have to divide that. There was no x square, but I was trying to take x square out, so I need to write 2 over x square. So that when you simplify this, when you distribute this, you will get that term. Let me take x cubed from the bottom. X cubed from the bottom, it will be 1 minus 1 over x cubed. So the idea here is try to take the highest exponent of x common from the top and bottom. Now we try to cancel out, okay? So what we do is we try to cancel out because x square is x times x, x cubed is x times x, x times x. So 2 of the x and 2 of the x will cancel out, right? Now you plug in the limit here. What do you get? So what you can do here is basically plug in the limit 2 over infinity. This will be 0, right? You see that? And 1 over infinity cube is infinity. This will be also 0. So what is left is 1 over x is left. So limit x tends to infinity, 1 over x is left when you plug in that limit there, right? Because when you plug in that limit, this will be 0, that will be 0 because what it says is a number divided by infinity, plus infinity or minus infinity will be 0. So that will be 0, this will be 0. 1 over 1 times x is left. So if you divide 1 over by infinity, it will be also 0. So the answer for this problem is 0, meaning when you go to the very right, the graph of this function goes to almost 0. That's what it is saying. So it goes to the x-axis. Okay, so you can plug in this into the graph, the whole thing into the graph, and then check where it goes when you go extreme right.